So, contactless drilling. Let's start there. So, obviously, we know the movie Armageddon, and we know the challenge. They need to send humans up there to install equipment to actually drill into the asteroid to deliver an explosive that would blow up the asteroid and make more debris. But that's a whole other thing. But the whole thing that pretty much failed for them was that the actual drills weren't holding up to the actual metal that they were drilling into, and that's definitely a problem. Like, not only would you have to bring all of that stuff into orbit in the hypothetical scenario that we send Bruce Willis into space to drill an asteroid and drop a bomb, you still would need to bring all of that stuff up there. And of course, right now, the reality is sending stuff into space requires mass, and the more mass that you bring up there, the more fuel you require, and there is a limit. There's only certain vehicles that can bring that stuff up there. James Webb Space Telescope is a great example where the spacecraft is way bigger than the bearing that they launched that thing up in, and so they had to fold that thing up like origami before launching it into the space, and then assemble it, unfold it in space. So that's extremely challenging, and if you're going to drill on someplace like Mars, how are you going to do that in a way that's economical for space, that we can do today, right? And not have to wait for something that can, space elevators or some other massive improvement in the ability toward launching things into space. Could we send a rover there with this contactless drilling robot? So this article from Interesting Engineering is really fascinating because it's a robot called Swifty. It's created by a San Francisco-based startup, Petra, which we'll have to get into. But basically, they were able to drill through the hardest rocks on the planet, which would normally destroy drilling equipment like we saw in the movie Armageddon. And they were using superheated gas. So Petra's semi-autonomous tunneling robot offers, as they say, fast and cheap solutions for infrastructure projects, which is a lot of what this next phase, Artemis Accords, the Gateway, and all of these things, that these long-term efforts we're trying to do in space, we're going to need to do some drilling. We're going to need to be able to set infrastructure in a similar way that we do to Earth, because that's what we know what to do. And they say that every method that's commercially available is a high-contact method that grinds up the Earth it contacts in order to remove it. Kim Abrams, the founder of Petra, said, "This is a completely new way to tunnel." So how it works, it says here in this article, the company previously used plasma to melt the rocks to drill through, but the extreme heat above 10,000 degrees Fahrenheit, over 5,500 degrees C, turned the rocks into lava. And so they wanted to go with a colder option so that the rock didn't turn to lava. And it looks like the drilling robot can bore a 24-inch tunnel through 20 feet of Cu quartzite, which is the hardest rock on Earth, harder than the bluestone granite, which is the type of rock that you normally have to dynamite in order to get anything to go through. So this robot has sensors attached to small rods, which touch the rock, and then the excavation is carried out by applying heat and gas. The semi-autonomous robot system can create 18 to 60 inch diameter tunnels through the hardest geologies with a non-contact thermal drill that melts any type of rock by heating a mixture of gas to apply heat above 1800 degrees Fahrenheit, 982 Celsius, that breaks rocks into small pieces. So what's really amazing, and we'll have this article here for you guys, is when you're thinking about what you're going to do there, you have to think about what does it take to accomplish that once you're there. So if you're able to do this with some kind of fuel and with gas, that is a much more manageable thing to launch into space. And then you can have someone troubleshoot that. Great example of this recently, the Mars mission InSight, which launched on May 5th, 2018 aboard an Atlas V from Vandenberg Air Force Base in California, landed in November 26th, 2018, and landed at Elysium Planitia, and was trying to drill and was unable to. The little drill that they were using ended up finding a stone, a rock, some hard surface it wasn't able to vibrate around, and they tried very hard to use the arm to push that little excavator down to get it to maybe move that thing out of the way, and it made some progress, but basically they had to stop. And when you're on Mars and not expecting that to happen, there's only so much troubleshooting you can do. So, again, the best solution is to send human beings. But you'll need to actually be able to troubleshoot. And this is where I'm trying to connect this whole thing, right? So, if we're going to go to the moon, if we're going to go to Mars, if we're going to go to an actual place, a physical landing place and not a station, and we're going to want to send humans there, humans are going to need the ability to troubleshoot. They're going to need a level of technical knowledge. And this brings me back to our earlier conversation with Bill Britton, who came on episode 250 to discuss securing our space future, cybersecurity in space. And that whole conversation was around the idea of how cyberskills are really important, and how, the next generation, they're trying to give them this kind of base level of skill that they're going to be able to use. And I think that's going to be extremely important in the long run, especially the short run here for space. It'll probably become at a certain point like second nature, like breathing, right? It's just a skill, reading even. If something on your space station doesn't work that you're living on, if something on your spacecraft doesn't work that you're living on, you're going to need to be able to troubleshoot that. Even on Earth, even today, right? I literally, I use Final Cut Pro 10 to edit things here on the podcast, and I kept needing to take so much more time. My hard drive kept filling up in the one that was holding all the storage. It's a few terabytes, right? It's a lot of information, and the only way I was able to really solve that was because I had the internet and the availability of all the resources of Earth here on the internet to access, to use, to learn something, right? A lot of the reason why I'm able to do this podcast is because there's so many people on YouTube and so many people online that I was able to learn from and build these skills on top of. What happens if we go to Mars? We don't really have access to that stuff when we're on Mars, right? You don't have access to YouTube, to Earth's YouTube. You don't have access to Earth's Google. You only have what you bring with you, right? So thinking about the long term of things, there's going to be something missing. You're going to have to bring those skills with you, right? Or else you're going to have to bring certain things with you ahead of time. And if you start experiencing new problems that you didn't expect, you don't have the resources to pull again, or at least it's going to be at a cost of time, right? Of how long it's going to take the light to travel back from, if we're on Mars to Earth, right? And so literally thinking about this whole thing, so on Final Cut Pro here, back on Earth, my problem, what I had to do was delete the cache. The cache was building up to a point. I looked at it the other day. It was 2.3 terabytes of proxy media, things that were rendered so that they looked good, so that they could export, all things that need to be done. But I had been working on that cache for easily a year and a half, and I wasn't sure if I could just delete it and move on with my life. It turns out I can just delete it and move on with my life. It just then requires me to render anything else that I actually want to use and work on and eventually export. So I was able to solve my problem here, but imagining how much more of a problem it would have been on Mars or the moon is definitely something to think about.